interruption to other participants to listen to our speaker. So please don't try to switch on your camera and mic. Please keep it switch off. And we have a chat window here. The chat window is for typing your questions for the question and answer session. After the talk, we will have a question and answer session. So you can type your questions, your doubts to the speaker in the chat window, and we will collect the questions for the question and answer session. One of our friend, Sharudat, is here to handle the question and answer session. Another instruction is, please don't try to share your screen. If you try to share your screen, it will be an interruption to other participants to listen to the presentation of our speaker. So please don't try to share your screen. That's a really important one. If you left out of the meet, when you trying to rejoin to the meet, there will be two options like rejoin now and present now. Please click on the button rejoin now. If you click present now, your screen will be shared. Please don't try to do that. So please switch off your mic and camera, and please use the chat window in a good way for the question and session. All other talks, unnecessary discussions in the chat window is strictly prohibited by the decision taken by webinar core committee. So please don't try to do that, and please don't share your screen. And we will have a quiz, UL Spacecraft quiz after this session on the same topic of our webinar, Travel Beyond Earth's Orbit. So all of you are requested to attend the quiz. The first prize winner will be awarded by a cash prize, and second and third prize winners will get a certificate from UL Space Club. So please try to attend it. It's a good opportunity to for all of you to acquire more knowledge. So please don't miss it. So I hope, Sriram, you are there?
Yes, sir, I am here.
So I welcome my friend and student fellow, Sriram ji, for giving more instruction about the talk and to give an introduction about our speaker. So welcome, Sriram.
Okay, Varnata. Good afternoon to all. Before moving to the formal introduction of today's program, I would like to announce the results of UL Space Quiz 31, which has been held after the last webinar. The third position is grabbed by an 8th grade student from GVHSS Atholi, Rifa Fatima K. And the one who reached at the second position is from Essex Medical College, Gulbarga, Karnataka, and he is Josh Thomas. And finally, the first prize holder, the cash prize winner sponsored by Cinder by Nature, is a +1 student at NSS HSS Kundamandanam, and he is Aravind V. It's my pleasure to share that the first two of them are close friend of mine, and Aravind, the one who also became the first prize holder of a state quiz today, is repeating his victory here continuously. Hearty congratulations to all the winners and participants. Well done, folks. Today also we have a webinar quiz. The quiz link will be posted at the end of the session via chat box. It will be only activated after the vote of thanks. The quiz will be based on your general knowledge on the respective topics and also about the things discussed in that session. The fastest and accurate answers by yours will be crowned, and a special surprising invitation is waiting for you. So be ready, and best wishes from the side of UL Space Club. So today is a little bit late. So can I move to the formal introduction, Shri sir?
Yes, you proceed.
Okay, sir. Once again, a warm good afternoon to all. Thanks to Varnatan for providing the instructions. I cordially invite all the veteran scientists, teachers, UL Space Club organizers, students, and all other participants to the 32nd session of UL Space Club's webinar series. We, the UL Space Club, is a foundation under the umbrella of Uralungal Labour Cooperative Society, stands for enriching and flourishing the scientific aptitude of students, especially in space field. Within a short time span of 3 years, we conducted many great offline events before the COVID. And exactly in May 2020, in the context of the pandemic era, we began this new journey called the webinar series. And it's going incredibly well for the past 8 months. Moreover, this is the first program by UL Space Club in the year 2021, as Varnatan mentioned. This is an inception for the new dawn. So we, the UL Space Club, wish you a very happy and prosperous year ahead. With that being said, let me move to the official obligations which has assigned to me. Today in the 32nd session, we have Dr. S. Ingersol as the lead speaker on the topic, Travel Beyond Earth's Orbit. When we take the chronicles of Sapiens, there were a time that when man wished to be a globetrotter, that is to travel all around this globe, which was the same geoid which we are part, Earth. But time traveled without the help of any time traveling technologies. The fascination to go beyond the horizon grown in the mind of all of us and rest was history, which is known to any space enthusiast. We send rockets, artificial satellites, animals, men, and women all to the space. In fact, you all know ISRO is going to send 3 Indians to the space in part of the Gaganyaan mission, in which a half humanoid robot, Vyomamitra, which was made here in the Thiruvananthapuram, was become a part. I redo the word no many times today, as we know, you know, etc. But actually, there are many untold stories, procedures, and unquenched doubts in our mind about these voyages. We have an expert who was the group director at LPSC under ISRO with us to explain all these matters. It's our privilege to have you here, sir. I'm gladly welcome you to the 30-second session of UL Space Club webinar series. Namaste, Ingersol, sir. And after that, we have all core team members of webinar committee here to give you the instructions when it's necessary. And our moderator is, as usual, Shajil sir, the one who controlling and developing our platform in each and every session. And he will gonna introduce our respected speaker. Our chief mentor, Ike Kutisa, the former director of ISRO, who is the backbone of the whole activities of the Space Club, is here with us. The whole webinar family, including the eminent scientists all over India, will be with us in this session too. And UL Space Club member and National Talent Search Scholarship, NTSC scholar, Sarudat will handle the Q&A session after the talk. The one who plays a major role in connecting us to UL, Damodaran sir, is here to express the vote of thanks after the session. Right now, this webinar is recording and streaming in the YouTube by our member, Adil Krishna. All set, good to go. So without any further delays, I invite the moderator, Shajil sir, to take over the session. Welcome, sir. Shajil sir, is there any technical glitches?
Can you hear me?
Yes, sir. Yes, sir.
Yes.
Yes. Yes. Then thank you, Sriram, for creating such a wonderful environment for these things. In every webinar, you are wonderfully creating a good environment and good ambience for the students to receive these wonderful talks. That's in this occasion, I really appreciate your excellence in this creating this kind of word art with the audience. Okay, we are proud of you. And today we met with some unexpected technical glitches, but we could tide over it with the help of technology. We could even change the link and we could transmit it, and all others are able to receive it all of a sudden. And we are so happy to tide over these things. And without taking more time, I am introducing our chief guest, S. Ingersol sir, to the audience. S. Ingersol, he was a scientist G from the India's private institution ISRO, and he was the group director and system reliability spacecraft propulsion systems and sensors, and he was part of LPSC in Bangalore. And he is a postgraduate from the Indian Institute of Science, Bangalore. And most of the students of these UL Space Club want to join in the IASC to take the higher education. That's the things. And we are so proud to have such a person from IASC. And he was part of this great organization from the year of 1983. And he completed around 36 years. He served 36 years of his hard work and his wholehearted support to this great organization in the development of our expeditions in space, and he was the group director, Systems Reliability Group (IPRC), and he was deputy project director, Quality Assurance Instrumentation, Semi Cryogenic Projects Division Head, Quality Assurance Instrumentation Division, LPSC ISRO, Mahendragiri, Deputy Division Head, Quality Assurance Instrumentation Division, LPSC ISRO, and Reliability and Quality Assurance Engineer, Aerospace Instrumentation, and Electrical Integration Engineer, Launch Vehicles, Vikram Sarabhai Space Center, Trivandrum, Radar System Engineer, Vikram Sarabhai Space Center, Trivandrum, and he took part major roles in designing and these things, the final touches to all the launching of all our satellite vehicles. And he's interested in development of testing, qualification of pressure, temperature, and transducers for aerospace applications, vibration measurements on high-speed rotational machinery, dynamic response testing for pressure transducers, special purpose instrumentation for cryogenic applications, estimation of uncertainties in propulsion performance and parameters, reliability studies in field of instrumentation. So he was so scrupulous in doing all these things, and he succeeded his job, and that's that may be the secret behind the success of all our launches. And he has participated a lot of research works and attended several conferences and paper presentation, and he even published a book in the name An Insight to the ISRO Satellite Propulsion System, that was published by LPSC in ISRO August 2018. He just retired from this great organization in 2020, and he was key contributor to the Chandrayaan-2 moon mission as a group director, system reliability, spacecraft propulsion system towards design and testing, qualification of spacecraft for complex missions. And he made a touch to all the activities, all the achievements of our great ISRO's achievements, and it's a great opportunity to have him to speak on travel beyond Earth orbit. Without taking much more time, I invite Dr. Shri S. Ingersol sir to present his wonderful talk on this topic. And we have some veteran scientists from ISRO and some students who are curiously waiting for these presentations, and teachers and our mentor Kutisar. And I invite all of you to this moment, even though we are a little bit late. And I formally invite Sri S. Ingersol sir to present his talk. Welcome, sir.
Very warm good evening to all of you. I think some mics can be muted. You can go to full screen. Yeah. Very good evening to all of you. My sincere thanks to Real Space Club, especially Mr. Saji, Mr. Sriram, Kutisar, and my friend Indu Kumar for inviting me to give insight into how human beings can travel beyond Earth orbit. I am very thankful to Real Space Club, and I understand this is the 32nd webinar series, and I have gone through the topics earlier covered. It's a very interesting and it's a very elite group of young people who have joined together to hear about and think about the space activities nationally and internationally. So let me thank you once again for having joined this webinar. Okay, this traveling beyond Earth orbit, whether it is really required, whether it is within our scope of the humanity to go beyond the Earth orbit, imagination takes us to places. But physically to go there, it's a challenge meted out to the human being. and we have traveled far and beyond with our robotic explorers. But how to reach and up to what point we can reach physically, or up to what point we can go by robotic exploration, all things I'll be covering. I have earlier also indicated that whether it is needed to leave the cradle of Earth, and also by what means we can leave this cradle of Earth, what are all the means, and how far and wide we can go with the present technologies. And also, it is very important that to travel beyond Earth orbit. That is, there's no doubt about it. And this first slide shows you many pictures. Actually, the one on the right is our complex Chandrayaan-2 spacecraft, which took us to moon. And in the bottom, you can see the New Horizon spacecraft, which traveled beyond Pluto and even Pluto in far out of the solar system. And you can see two objects. One is called the Mercury mouse, Gerasimingo, that is a comet. And also on to your left, you can see the farthest object which man could go, and not man could go, our robotic spacecraft could go, and then learn about it. That is called the Alkima Thule, or the Arrokat ice man type of a structure. We have traveled far and beyond, and what are all our intentions? Why we should go? Let us discuss in this seminar or webinar for around 30 minutes. I will take 30 to 35 minutes. The time may not be sufficient, but still I will try to go very quickly into what is our need of going into by traveling beyond this orbit. Next slide, please. He's the man I revere him most, Professor Carl Sagan. Every one of you must be knowing, a greatest astrophysicist, who says that our future depends on how we understand the cosmos, and then our survival as a human beings will depend on how we are understanding the cosmos. That is the key idea behind my talk. Actually, Professor Carl Sagan, I like him very much, and I would like every one of you to read the book Cosmos, or the serial Cosmos, which every one of you should read and hear this great man. Our future depends on how well we understand our universe. That is the key message. The talk is also purely based on this. Next slide, please. One thing, going into space, it improves the quality of life on Earth. That is, there is no doubt about it. Our artificial spacecrafts, which we have sent to orbit around Earth, improves our life. In India, it is a great success that a socio-economic development of the country, which is not possible by conventional means, has been undertaken successfully by ISRO with the backing of the government of India. And so we can very well understand that it is behind all our giant leap or giant progress in our country. The socio-economic development is basically tied to how we are going to use the space around planet Earth. That is the first intention. The first satellites which were just sent to establish a link, satellites are supposed to be called as repeaters. They are dumb technical things. They just receive and transmit whatever message sent to them, and they keep an eye on our weather conditions. They allow us to navigate precisely know our position. It's a great tool for disaster management. It is a great tool for economic progress of a country like India. And also, the satellites are great tools for uniting us together. A country which is far and wide, with many languages, many castes, many creeds. The technology, the space technology or the satellite technology keeps us all of us united. And that is the only technology through which we can progress. I hope you all will accept this important message. So we have the telecommunications, the natural. I have forgotten to tell one thing about the natural resources management of our country and of our neighboring countries, or overall planet Earth. We can get a good idea of what resources we are having, and also the way in which we are spending our resources, the rate at which we are spending our resources. That is also very important for any country to plan its progress. So that is done all by these satellites or spacecrafts, which we insert into an orbit around our planet Earth. Next slide. Can we go to the next slide, please? Yeah. The space gives us a new vision of our planet Earth. That's very, very important, actually. When you take off from Earth and put our satellite in different orbits for different applications. If you want to do a communication type of activity, you have to park it in a geostationary orbit, or 36,000 kilometers away from planet Earth. If you want to do a remote sensing or to understand the natural resources of the planet Earth, we have to put it around 600 to 900 kilometers in a polar orbit. If you want to have a navigation type of an application, you have to have a constellation of 6 or 7 satellites and then put it in a geostationary orbit. There are multiple applications, and space gives you a beautiful vision of the planet Earth. It's philosophical also that once you move away from a place and then look at it impartially, as an external observer, you will be able to understand much more than thinking from yourself or talking from yourself. You move away from the place, look at the planet Earth, and then understand its resources, and then many other applications. So it gives a new dimension into the human vision. Our forefathers really were observers. They were physically observing things, but they have not stumbled upon a system called science. They were physical observers. With their intellectual capabilities, they were able to observe not planet Earth, the cosmos. They were able to visualize what is going all around us, but they had their limitations as far as the sight is concerned. But the human beings, as on today, with the technology of the spacecrafts, have attained a beautiful new vision. And we have started understanding about our own home, the planet Earth, our own system, the solar system, our own star, the sun, and also we have learned to understand beyond that. We have learned to understand beyond. That is very, very important. What we have learned is very little. Always it will be very little only. And this is just a new beginning. It's just a new beginning of understanding our own planet Earth and also the whole universe or the cosmos. Next slide. So do we have to leave our cradle? Any baby to grow, it has to get out of its cradle. A ship has to sail into the ocean to really perform its task. So it is impertinent that we have to leave our cradle to learn more. That is a basic philosophy which all we know. And there are some fundamental questions beyond the socio-economic development or the technological circus which we do in applying this technology for development of the humankind. We have some fundamental questions, philosophical questions, which we have since time immemorial, like where do we come from, how does life exist only on planet Earth, or what will happen to us in the future, or will be alone in the universe. These are all questions which we have to answer in the course of our investigations. And today we have the ability to understand, or at least I will say we have developed the ability to ask questions. To ask questions is very important rather than getting answers. Particularly as children, you should not hesitate to ask questions. Questions are important. We may get answers as on today, or we may get it tomorrow, or you may not get the answers in your own generation, maybe in the next generation. But we have the right technology, we have the right philosophy called science, and we have developed our tools like the launch vehicles or the rockets, the spacecrafts, through which they are now our eyes and ears, so that we can understand the cosmos. So the question what I have posed you, they form the basis of our goals to explore. Let me say first, our neighbors. These are the neighbors like Moon or Mars, and then beyond that also we can go, so that we understand what is our solar system and what is our own galaxy, or are there nearby stars to which we can go. So these philosophical questions will set our goals for going far and wide, and what is the technological enabling we have, how far we can travel, and what is our limitation as on date today, and maybe in a course of another 100 years, what is possible. All these things we can discuss. But certainly it is time to leave our cradle of comfort and then venture into the nearby places. Next slide, please. Okay, this cosmos can be visualized only through technology. With bare eyes, our limitations are very less. With the advent of the telescope, we had a beautiful vision of our nearby neighbors, but with the advent of the spacecrafts, we have the ability to go a little more. And the Indian space missions, that also are very important. We can talk about many things, but think globally and act locally. That is what technologists like me do. Even though we can talk many philosophical things, what we have done in our own backyard, that is what is very important. Having given an economic progress, a way for economic progress, I won't say economic progress we have given, a way for economic progress of the nation with the help of space science and technology, and having satisfied with the fundamental requirements put on ISRO by the government and by the people, we have stepped into the next gear. We can say the next phase we have stepped into by looking into our neighbors. The Moon, the Mars, that missions we have done. We have traveled around 4 lakh kilometers to Moon, and then we have traveled around 64 crores of kilometers to Mars. And in the course of these journeys, we have learned a lot. I have listed down what are all the new technologies with which these missions are possible. These missions are possible only with the acquisition of very important technologies like very precise navigation, autonomous decision making, deep space communication. So all these things to acquire is very difficult, and no government or no other agency from other countries will give it to you for love or money. That is the thing you should understand. Even if you are ready to give money, they may not part with this type of technology. So we have developed our own very critical technologies in doing such missions of going to Moon and Mars. We are progressing on the second phase also, and even I can call it the third phase also. And I have put the third thing, the international missions, which I became fascinated with, travel beyond Pluto, using a mission called New Horizon. That is not an Indian mission. It is a NASA or United States mission. And thereby we could go to beyond Pluto and even far beyond that. And also another mission called Mission Rosetta, where instead of going and plunging out of solar system to meet some cometary fellows, the fellow who is coming inside, the comet which is trying to come into our own backyard, we try and go and investigate. That is a very important idea, that to go far and beyond, it requires a lot of time. But when the fellow comes here, why don't we investigate and understand him? That is an ingenious mission called Mission Rosetta, and thereby we had an opportunity to understand the primitive makeup material of our solar system. How the solar system was made, what are the primitive building blocks of solar system. These we could understand to a little extent by investigating such occasional visitors who come from outer space and then come into our own nearby orbit, so that we can go and do them. So it is, these are all the ingenious way of human thinking. That's what is very, very important. Next slide. Next, yeah. So these are, I have listed down a lot of Indian missions which we have done. We have put more than 109 spacecrafts, 77 launch vehicles, student satellites we have made, 2 re-entry missions. We have sent an object into planet Earth, around planet Earth, and then brought it back. That is the forerunner for our human mission called Gaganya. We have done it. We have the ways and means of exploring our own planet Earth, our own neighbors, and then we have the ways and means of going beyond Mars also. The technology is available, only it is a question of economical enablement, which will take us into further and further into our solar system and beyond. We have gone to Moon, we have gone to Mars, we have gone to Moon twice, and still our orbiters are going around Moon. We have gone to Mars, the Mangalyaan mission, which took a path around the sun and traveled far and wide beyond 66 crores of kilometers. Over a period of 10 months, this journey was made. And we had a first rank when doing this mission, that India was the first country to successfully enter into a Martian orbit, whereas the other nations have failed most of the times, and on the 3rd or 4th attempts only, they could even successfully orbit around Mars. Still, even now, there are missions which are going to Mars. The Perseverance rover is on its way to Mars. It is carrying my name on it. I have applied, and then they have put my name on a microchip, and then it will be going to Mars and land on Mars. So these are all things which make us happy, and also to put Indian science in the proper perspective. That is very, very important. We are the largest scientific manpower in the world. With all these largest scientific manpower, whatever we have achieved may not be sufficient, but with the participation of young people in future, and with an economic enablement from the private organizations and private enterprises, we will be able to do more. That's what I believe. Next slide. Next slide, please. Yeah. So these are all the launch vehicles. I don't have to. You are all very learned people. We have the 5 launch vehicles which I have put, in which the GSLV Mark II and Mark III and the PSLV are now operational vehicles. That is very, very important. India has an independent access to space. That is very, very important. We don't have to depend on any other foreign nation to have an access to space. We can develop our own spacecrafts. We can develop our own rockets. We have our own technology, so that the country doesn't depend on any other foreign nation for us to go into space. That is the first thing which I would like to tell this younger generation. We can take a spacecraft of 4-ton class, 4-ton class, and go around go to the geo orbit. That is the maximum capability we have as far as launch vehicles are concerned. The PSLV is a workhorse and the most reliable and then the most accurate launch vehicle from which we can go to these. PSLV can be coined to take any mission, like a navigation mission or a communication mission, or in fact we went to moon the first time and went to Mars for the first time with a humble vehicle called the PSLV. So we did it with a different type of mission. That is very, very important. The global nations like ESA or NASA, they had giant launch vehicles with which easeless they can travel to moon or Mars. They had the capability of a very heavy lift launch vehicles, but we never had that luxury of having heavy lift launch vehicles. We did it with our own PSLV. We did it with our own PSLV, went to Mars. We went to the Chandrayaan 2 mission was done by our own GSLV Mark III vehicle, fine-tuned, and took an element of risk in carrying a payload of 3,850 kilogram, a complex orbiter come lander come rover, all built into one satellite. It was lifted off from Sriharikota with a total weight of something like 3,800 kilograms, and having a mission of going to moon is a little bit different from going to a geostationary orbit. So all these types of different types of missions which we could accomplish with whatever we have. That is very, very important. We can dream, but we have to do, we have to act. That is what we have done with all these launch vehicles. And we are developing the semi-cryo engines and stages with which we will be able to take something like 10,000 kilograms of payload into the low Earth orbit. It is possible. It is going to happen within a period of few years. Next slide, please. So when we are a resident of planet Earth, we don't even feel the enormous movement with which this Earth is rotating itself, or how it revolves around the sun, and also the sun as a mother takes all its babies, the solar system babies, into the Milky Way galaxy. We could even not imagine the velocities with which these are happening. Only we have a relative velocity of comparing another thing which is traveling beside us, we will not be able to feel these velocities. That is what is very, very important. A velocity of a rocket as it leaves to put a satellite, it has to be around 30,000 kilometers or even 40,000 kilometers per hour. And the earthen bodies or the natural bodies of our own planet, our own Earth, and then the overall solar system, how it moves. You just imagine what is the type of velocities nature has given to these objects. But for man-made things to gain such velocities, we don't have to gain such velocities, but think about how such enormous velocities are delivered to the spacecraft. That is what all about the launch vehicle and spacecraft technology is all about. Next slide, please. Next, yeah. The satellite, which is the final passenger which has to go into space, has to develop, has to be delivered or thrown away or kicked into the space by the launch vehicle with a definite velocity or a momentum given to that particular payload. The overall aim of a launch vehicle is to deliver around something like 10 kilometers per second velocity to the spacecraft so that it remains in orbit. And for an object which has to leave the Earth's gravity and then go into interplanetary space, still more we have to achieve. So you can see that that is what is mentioned. The geostationary, the spacecrafts themselves have some small propulsion systems which they add some delta velocity to the already developed velocity given by the launch vehicles. The launch vehicles are expendables, and then they deliver a velocity of something like 10 kilometers per second and leave them at a point very well oriented in space and at a precise point in space. From there on, the spacecrafts have to function for a period of 10 years or 15 years, and they have their own propulsion systems to take them into specified orbits. That is very, very important. That is why I have put this slide. You can see that the spacecraft, what delta V it can add by itself, by its own propulsion systems. That is what is mentioned here. For an Earth, for a moon mission, how much delta V is added by the spacecraft itself. That is what is depicted in this slide. You can see the Chandrayaan, the satellite, which was, as I told, is a complex 3-in-1 satellite. As it took off from space, it is a complex satellite. As it went to the moon, it was complex. Then it was separated into two in the moon's orbit. In the moon's orbit, that is very, very important. It is separated once the orbiter goes around the moon, and the part of the spacecraft, which is the lander, has to go on land, and then a rover which is sitting inside the lander has to come out and explore planet Moon, not planet Moon, natural satellite Moon, but we failed to do that at the last leg of the journey. Yet Chandrayaan 3, which is going to happen within a period of another year, will overcome all these difficulties, and then we will be able to put our rover on the surface of Moon. Basically, I get delighted by how the laws of physics are adhered by these complex machines. Next slide. These are applications of space science and technology. Already I have told you. To make a giant leap in progress for humanity, the space technology is one beautiful way of achieving it. You can do it smaller way over a period of 50, 100 years, but to have a giant leap, you have to catch hold of a technology which enables us to do that. That is what is called space science and technology. So we have achieved a giant leap by doing this. And these are applications, the earthen applications. And once you develop these earthen applications, for example, the remote sensing, you are doing the same remote sensing on Moon, or you are going to do the same remote sensing around Mars. So whatever technologies which we develop to go around our own planet Earth are beautifully translated into missions of interplanetary missions. That is what is important. Only the navigation is different, the place is different. It was planet Earth over which we were doing our missions, but now we have learned how to take them, how to make them travel far and wide with a beautiful, precise navigation, which India has acquired it masterfully and beautifully than any other nation in this world. So we can travel far and wide to Mars or Moon and then repeat these missions and then gain insight about our neighbors. Next slide. Next. So I won't go much detail into what is a spacecraft, what does it contain. I have listed down what are all the constituent parts of a spacecraft. After this presentation, I hope can be shared to the younger generation, so that they know that what is inside a spacecraft. The spacecraft is powered. It has got a structure. It has got its own small propulsion systems to take it into an orbit and to maintain that orbit, and then to know its position and then correct its orbital positions, and also the type of the data gathering it has to do. It is not just like that we have put some object into space, but it has to capture the data and then forward this data onto the ground system. So we have the beautiful description, and it has to function under extremely unfriendly conditions in space. That is what you should understand. It faces a temperature extreme of -200 degrees centigrade to +200 degrees centigrade. It has to generate its own power by solar cells, and even for missions which are beyond Moon and to Mars, we may require radioactive sources of power. The normal sources of power like a solar cell may not be sufficient for a mission which travels beyond Mars. That is also there. So the power systems are there, and the communication systems, and then the control systems. These are all beautifully done by our own ISRO scientists. That this is basically what a spacecraft is. It has got many subsystems that function together, so that we get beautiful data out from either from planet Earth or from our own neighbors and even beyond that. Next slide. So these satellites are tested in simulated environments of space. We simulate evacuated vacuum conditions. We simulate the temperature extremes. We simulate with vibration. We simulate with shock, so that whatever it has to endure, it has to face during its lifetime in its actual home, the space. We simulate such conditions on ground and then test it. Even whatever it faces in space, beyond that we test it at ground, so that the mission works well and doesn't fail in space. In spite of all our imaginatory testings for the various environments these spacecrafts will endure during its space journey, we face failures. Because of complex electronics, complex communication devices. So failures are also part of the systems, but then we have the philosophy of redundancy for critical systems. Redundant electronics probably we can have, but a redundant spacecraft or a redundant propulsion system is always not possible. So we have to have some philosophies of reliability, so that to the maximum extent we have redundancy in critical electronic systems, and then some systems which we cannot have redundancy, we test it and qualify it to whatever extent possible, so that it doesn't fail in space. This is all what we can tell about it. Next slide. So the types of orbits, probably my friends who are all space enthusiasts will know that going around planet Earth in a geostationary orbit in an equatorial plane, 36,000 kilometers away from Earth, you can see that the dish antenna and the spacecraft are always looking at each other and try to be looking as static, but both of them are moving. The Earth is moving in 24 hours. The spacecraft is going around the Earth in 24 hours, so that we remain, look apparently as static observers. That is what the communication is made possible only by such type of spacecrafts. We have 3 spacecrafts. If we have in the equatorial orbit, we can deliver any message from any point of Earth to the other point of Earth. That is what is important. You must have a minimum constellation of 3 spacecrafts in the geostationary orbit, so that you can take any message from any point of Earth to the other point of Earth. Seamlessly, it can be done. And you can see the polar orbit, which is basically the resource monitoring orbit, which travels around the North Pole and South Pole. Almost in 90 minutes, you go around the Earth, whereas the geostationary orbit takes 24 hours to go around the Earth. Here, in 90 minutes, we go around planet Earth, and like a broomstick, we can scan planet Earth, take pictures, either in the visible spectrum or the any type of spectrum is possible without cloud cover. With cloud cover, we have developed technologies not only with visible light but with other spectrum also. We can cover the planet Earth and understand its resources, and then have lots of applications on remote sensing. Navigation is another part. The Molniya orbit is another orbit in which you can always, for the countries which are in the northern latitudes, they have an orbit called the Molniya orbit. Okay, next slide. Next, yeah. These are the spacecrafts. How do they function? If you throw a stone up in the air, it will come back. If you throw it with higher velocity or a higher momentum, it will go little far, and then definitely it is going to come back. But if you can throw it with a particular momentum which is able to deliver the spacecraft with a velocity of something like 8 kilometers per second, it will be able to orbit around the planet Earth. That is what is very, very important. You have to make the object go around the planet Earth, so that it acts as a repeater, it acts as an eye in the sky, so that you will be able to send a message. And because of its vantage position of the spacecraft, it is able to redirect the message almost into 1/3 of the globe. It has got a beautiful vision, so that it can reach. Whereas terrestrially, it is not. We will not be able to reach such distances with a signal or a message. That's what is important. The spacecraft is continuously trying to fall because of the Earth's gravity, but the momentum what we have delivered, the rocket which has delivered the momentum, is able to keep it from falling and then going around the orbit. That is what is very, very important. The spacecraft tries to continue to fall to the Earth, but the momentum which we have delivered, that is sufficient. At the injection, what momentum we deliver is important, and that is sufficient for it to keep it in its orbit for more than 10 or 15 years. We don't have to do any higher thrust or deliver more thrust to keep it in orbit. They may have some small orbital corrections, for small thrusters are there, but basically the rocket delivers the momentum. And that is what is very important for the spacecraft to go around planet Earth. And as I have told earlier, Whether you go to moon or Mars or whatever it is only a question of going from one place to another, doing the mission management or taking the path we have to go. But the basic mission is to go around the object. That's what's important. Next slide. Next slide. Next, yeah, this all. Next, please. Okay, what sort of means we have to use? An intelligent means to whether we should go as human beings and then go and explore the planetary body, or we should send robotic explorers. That is the first question which we ask. Okay, so we are basically explorers. We explored on foot, continent to continent. We explored with the ocean, with ships from one continent to, I won't say ships, catamarans are small objects with which we traveled around planet Earth. It took around an year for a human being to go from one place to wander from around the Earth. We were wanderers and then hunters and gatherers. But now our technology is to have rockets and satellites, so that we are wanderers and gatherers, but now in a different scale. Using science and technology as our tools, we are able to wander beyond planet Earth and go beyond solar system, and even to understand about stars, which are much beyond than our small solar system. So these spacecrafts, which we know that we have gone to moon, probably 12 people only have landed on moon and then walked on moon, and we are planning to, the human beings are going to Mars in another 20 to 30 years. They may colonize Mars, and right, the technology stops at that point. Human beings to physically reach there to a mission like Mars is what is possible as on today. Spacecrafts, they have crossed the solar system, gone beyond the solar system, until traveling. We have sent our messengers into the interplanetary space. But human beings, the limitation is, as on today, with our own propulsion systems, it is only up to Mars. We cannot travel beyond that. But still, that will all be overcome in the time of these youngsters who are listening, who may develop beautiful new technologies. Next slide, please. Yeah, these are all, I'm putting again the same significant space missions, what we have taken. The Apollo is definitely a beautiful mission in which human beings went to moon, but of course not only in the spirit of exploration, but in the game of one-upmanship. I am the supreme sort of a philosophy which the Americans wanted to demonstrate. That is why they went to moon. But definitely those technological missions, even today, it is very difficult to emulate such missions. Beyond 1972 or so, human beings have not traveled to moon. They are going only around planet Earth, and they have probably understood that there is an element of risk and also the money involved in going to moon or beyond, which has to be judicially justified. Okay, next slide, please. This is how our moon mission we went. We had a smaller launch vehicle called PSLV, whose capability to carry a payload of heavier masses was limited. So we had calculated burns, which the spacecraft went around the Earth for 4 or 5 orbits, and then it took a trans-moon journey. And going near the moon, the spacecraft velocity was reduced and it got captured by the moon's gravity. That is what is very, very important, to travel beyond the sphere of influence of the Earth. That's the gravitational influence of the Earth. And then go beyond that, and then in that path, you have to go somewhere near a flyby type of near moon, and then allow the moon to capture this object as its satellite. That is very, very important. That's what we did. And still, it went for an orbit of around 100 kilometers around, circular around the moon, and its mission was for less than 1 year. Somewhere in 2009, we have done this mission. Next slide, please. And we were the first country to develop, to understand there is moon, water is there on the moon. On the poles, we understood that water is there, and it has got very significance. The understanding of water availability, the water when it is available, then it can be an industrial base. Moon can be developed as an industrial base. Our future explorations, we can use moon as a base and then go into other planets. And also, there are precious minerals probably we can dig from moon and bring it back. A lot of things are possible, but with severe economic constraints. So we were the first nation to discover water on moon. Next slide. The second Chandrayaan mission, the second mission was attempted last year. And then, as I told, the complex mission, which had to land, which we wanted to land, but we could not. We crash landed on moon, and this mission was a beautiful mission. And the last leg of 13 minutes, everything was perfect. I can say the most perfect mission which ever ISRO has gone through. And the orbiter which we have put around moon is still orbiting around moon and giving lots and lots of information about the moon. Why we should go to moon? That's the question which you can ask. Moon is like a history book. If you want to read the history of planet Earth, we have to go to moon and read, because planet Earth has modified itself because of its living presence. The living beings have transformed this planet Earth beyond recognition because of the presence of life and other developments. Whereas a pristine historical Earth, we cannot see it now. So we have to look into the moon to find out our history. And also, as I have told, some economic other criteria are there. We can mine from moon and things like that. So this Chandrayaan mission, I was part of it, a wonderful mission, but still we could not achieve it, but it will be done later, maybe in a year or this year end, or maybe next year it will be done. Okay. Next slide.
Mr. Ingersol, can I take a half a minute?
Yeah.
Can you come back to the old previous slide, Shajil Mash?
Yeah.
Just previous slide. Here, our students must be viewing a person who is very familiar to us, Padmanabhan, P. Padmanabhan of URSC. I saw it. That's why and he has been an integral part of us. That is why.
Yeah.
Okay. Thank you. Sorry for interruption.
In fact, to tell to the students, I was there throughout this mission, and to see the graphics. Physically, you cannot see these spacecrafts, but the graphics or the simulated, not simulated, the actual flight data in a visual way, you can see that the spacecraft is obeying the Kepler's laws. I always used to have an eye on physics. As it comes near the moon, its velocity will increase, and as it goes far off, its velocity will decrease. I'm physically wondering about our wonderful scientists 400 years ago who could coin such laws, and the spacecraft what we have did now are perfectly obeying these Kepler's laws. This is one thing which fascinates me basically. And we can do all remote commanding, all remote operations, but still the laws with which these things function I used to always tell one thing to the students, that the human beings, the beautiful people, the laws which we discover on planet Earth as a hypothesis, and then proving that time and again that these are right, is not applicable only for planet Earth and its surroundings. What the laws with what we discover is applicable for any object that is revolving in any other solar system or any other planet which goes around other suns. So what we do is not only for our own survival or our own understanding, but these laws of physics are applicable for other systems. That is the greatness of our human beings. Next slide. It's just a okay, next. So this is basically the flight sequence. You can see the velocities. Basically, if you see the table which you see on the right gives the increase in velocity of the rocket. The satellite is on its head. It increases its velocity as every stage completes its operation or is in operation. Basically, the rocket is a wonderful machine. It's a very complex machine. Its life period is only for a period of around 20 minutes. It loses its life, but it achieves its mission. It delivers the momentum to the object. You can see the velocity something like 10 kilometers per second as it injects the spacecraft into the orbit. First it achieves only an earthen orbit. And then we increase the earthen orbit into a technology, into Hoffman's transfer orbit, and then we move into the other nearby satellite. Okay, next slide. This is the beautiful spacecraft. I can always be very happy to see into the spacecraft. With its legs, lander legs, and then how it is cocooned by the heat shield which protects the spacecraft during its atmospheric run. As it crosses the atmosphere, that is the most dangerous time for the spacecraft to keep it alive. So it is protected by a heat shield, and after some time the heat shield beautifully ejects out, and then the spacecraft is taken into space. Next slide. Next. Next. These are all certain numbers, actually, how each of these stages are performed. The last column says that how much velocity it has gained or lost in each of the stages of operation. You can see that the cryogenic stage gave an additional velocity of 76 or 80 meters per second to this mission. Because of that only, the orbiter's life has been extended from a period of 1 to 1.5 years. Now it is estimated that it will be there for 7 or 8 years. The efficiency with which the cryogenic stage performed and delivered an impulse to the spacecraft has enabled its life from period of 1.5 years to 7.5 years. See how much beautiful science we get to do when the life of the spacecraft is extended by few years. This is what the beauty of these technologies. Next slide. Next. Yeah, these are all events which are destined or what we intend to happen and how it happened in the actual flight. This is how the technology meets our intention, and some real-time decisions are also taken there on the launch vehicle. The precisely timed events, and then based on the thrust developed and then the tail of thrust developed, these decisions are taken. You can say how beautifully these matches with our expectations. That is the victory which we get as a launch vehicle personality. Next slide. These are all what we saw was the earthbound putting the object into the space, but then we have to go to orbits around the Earth, around 5 orbits around the Earth, and then the translunar injection, in which we go to the moon straight away and then get grabbed by the moon. Next slide. Okay, then the lunar burns. You go into highly elliptical orbit around the moon first, and then slowly make it as a circular orbit around the moon, so that that orbit is useful to us as a remote sensing around the moon. That is what is important. And in the process, deliver the necessary velocity, or rather reduce the velocity of the spacecraft, so that it is in the capture of the moon's gravity. That is what is very, very important. Next slide. This is how we planned. We had planned to deboost the lander and then break its velocity, and something like less than 2 meters per second velocity should be there at the time of landing. The horizontal and the vertical velocity should be less than 2 meters per second on moon as it lands. But due to some mission problems, which we could not do that. But this is what was planned for this mission. Next slide, please. Next slide. This is a Mars mission. Anyway, I have talked about it. We went to Mars and then went around Mars. First nation to do it in its first attempt. Next. Next. These are typical profile with which we did it, and then it went to Mars 66 crores of kilometers, a journey of 10 months. It is very important that at the final phase of the mission, after 10 months of this interspace journey, the launch where the spacecraft's propulsion system has to come alive, and then again it has to get active, fire, and then reduce the velocity, reorient itself. It was a feat achieved for the first time after 10 months, making the propulsion system to once again wake up and then perform its mission. It was a beautiful experience that we achieved. Okay, next. Yes, next. These are all how we achieved. If you see, these are all our own missions. How we insert the spacecraft into a Martian orbit, reduce the velocity, reorient it. Actually, in fact, 180-degree opposite, we have to turn the spacecraft, fire it in the opposite direction, so that the velocity gets reduced, so that the Mars is able to grab it as a satellite. That is what is very important. That was achieved. So now we know it is not only the human, the Indian missions. There are some 5 rovers, 4 or 5 rovers. 4 rovers are already there on Mars. The 5th rover is on its way, and then we have gone to Saturn using a spacecraft called Cassini, and then we have orbiting telescopes, which gives us a beautiful picture of the cosmos. We can go far as a robotic explorer only into our solar system, but to understand more about the solar, the suns, about our own Milky Way galaxy, and the other stars which are far away, we have to use only our telescopes, which are ground-based, and also the atmosphere which protects us from many things harmful to the human beings is a great handicap as we visualize the cosmos. The telescopes are at a great handicap when we see into the cosmos because of the optical things, obstacles which is as an atmosphere crosses. So to overcome these obstacles, we send telescopes into space, the orbiting telescopes which go around Earth and then go above the atmosphere, so that these optical problems are solved, and then look into the cosmos and then send the visible information as an electronic information, so that we look into the cosmos with better eyes. That is what we do with orbital telescopes. in different spectrum of light, not only in the visible, the X-ray spectrum, the ultraviolet spectrum, the infrared spectrum, many things we do, and the astronomers do that, and they get lots and lots of information about our own Milky Way galaxy and beyond that. Next slide. Okay, we can say that spacecrafts from almost 5 or 6 nations are there, whose presence is almost becoming a space junk around our planet Earth. We are facing problems of space traffic and then space junk around planet Earth. But we have sent robotic spacecrafts to other planetary systems, and we will talk about the New Horizon and the Rosetta mission. Next slide. The New Horizons is a mission which excited me beyond any limit, because the Pluto as an object, it was discovered somewhere in 1930. It takes around 280 years to go around the sun, but before it has gone around the sun, once after its discovery, we have gone to Pluto. We have made a flyby to Pluto. That gives me a physical feel of, even if Pluto is not able to do an object around sun, but human beings over a period of 9 years taking off from Earth and then have made a flyby of the Pluto. They have not landed on Pluto, flyby of the Pluto, and then gone into interplanetary space. That is a beautiful mission. Next slide. This is how we travel from our own cradle and into the and you know, probably the Kuiper Belt is a belt of planetary embryos, or rather unfinished planets, smaller objects which go around the trans-Neptune, beyond Neptune, farther into the solar, outside the solar system. There are thousands of objects going around the solar system, and these objects, once in a while, they come into our own gravitational influences because of the planets like Jupiter and Saturn and things like that, and they come here. But we have gone to the Kuiper Belt. Now we have gone to the Kuiper Belt, crossing the Pluto, and then, for your information, we have traveled almost 1.5 times beyond Pluto, and then gone. Met another Kuiper Belt object called Arakoth. It's called Arakoth. It is called Ultima Thule. We have gone, this spacecraft New Horizon has gone as far as that. That is crossing the solar system and then beyond into the Kuiper Belt. Next. This is what is called the Kuiper Belt, that is beyond the trans-Neptune. In the solar system's plane, these objects are there, in which they come occasionally inside and then come as visitors and then entertain us and then give some lighting works to us. Next slide, please. This is how this New Horizon, taking off from planet Earth, from the solar system, how it has moved away beyond Pluto and how it is moving, and then how it has reached an object called this Arakoth. The first slide, if you remember, you can see that on the left, you can see that object. Next. Next. So the Pluto was just a hazy object, which even with the telescopes, you will not be able to see anything. Its presence is very difficult to be identified. That was what we know about Pluto, but now we know what Pluto is. See the beautiful Pluto and its moon, Charon. Pluto has got some 5 moons, and now we know about Pluto, and it has got some 5 more moons, and beautifully. This is what the spirit of exploration, you know that. The Pluto, which was just a hazy object, which doesn't give us a beautiful view, but an object which is far off by 39 astronomical units. You all know what is an astronomical unit. That much distance, now we have gone travel wide, and then looked into Pluto, not only Pluto, its icy moons, and then understand. The scientists are thrilled that it's having a very active surface and subsurface. We thought it will be a frozen planet which will not have any active things, but scientists are thrilled to see it's very active on its surface. Next slide, please. So the ancient relics, that's what I was telling. During the formation of the solar system, probably some 4.5 billion years ago, these objects are also got formed. Some of them got converted into planets, but some of them were left as unfinished planets, and their relics, these are the prime building blocks of the solar system. And these, by looking at these building blocks, we will understand our history. That is what is very, very important. This is the bottom one. You can see the Arafat fellow whom this New Horizon recently made a flyby and then took. It is like a snowman. It's a small object. What do we gain from it, you may ask, but still to have a spirit of discovery, it's very, very important. Next slide. See, these are all the mission details. I'm not going into that. The distance what it has traveled is 6.6 billion kilometers. 6.6 billion kilometers. Unimaginable. 660 crores of kilometers, which is 45 astronomical units away from the sun. That is what it's a beauty of this mission, and still it is traveling. Its mission life is extended. Once it crossed Pluto, they extended its life up to Arafat. And after that also they have extended the mission up to 2021. It may be our representative of a robotic explorer which is traveling into the interplanetary space. It may go from Kuiper Belt to even Woods Cloud. That's what they say. Next slide, please. So these are all things which some numbers which you can always get enthused about. Next slide. So this is what a mission with a greater impact, and certainly it has an impact on me and on these children. Next slide, please. 10 years and 3 billion miles, that was what they thought, but now it is going beyond that, more than 14 years. It has gone. Next years. Next. Pluto in detail than ever. Beautiful. Than ever we had the vision of Pluto. Next. Instead of going there and going there around 660 crores, a fellow who is coming from there, why not to have a rendezvous? That is the beautiful mission called Rosetta. Instead of taking the trouble of going there, why don't you meet the fellow in your backyard? This is a beautiful coined mission, and it was done by European Space Agency, and it made a lander to physically land on this comet. Beautiful. And this comet, which as it came into the our own solar system, the inner solar system, and then as it crossed the sun, it is basically an icy object, and it didn't lose its life. It almost melted away, and then the gases with it expanded out. We could understand what this object is. These are all the relics of the solar system, and even the primordial formation of the solar system when it happened 450 crores of years ago. Next slide, please. Yeah, this is what is called the Mission Rosetta. You can see that satellite Philae, which is sitting on that comet. A beautiful mission, actually. You can see that object. You see this object and think about that object, Arafat, which is far off, beyond Pluto. And this fellow came near our Jupiter, and then it went up to the sun. See the resemblances. Instead of going there, you are taking a call on this comet when it came into our backyard. This is the beauty of this mission. Next slide. This is a beautiful mission. You can see the timeline, how it took its velocity. Actually, the spacecraft gains its velocity by multiple sling maneuvers. You understand that as it comes near a bigger object, of a natural object, its velocity gets increased. So it took 2 earthen sling maneuvers, and then it took a Jupiter sling, increased its velocity, and then the object was coming far and wide from the outer skirts of Neptune, and it came in and it made a rendezvous. That's the beauty of this mission. You can see the mission timeline and things like that. You can view it in beauty at your leisure time. Next slide. So this is what we meet at our backyard. Rosetta's task was to get this object, which was coming about 3.5 AU astronomical unit from outer space, and then we go into detail about the investigation by landing an object onto the comet. Next slide, please. Yeah. Next. So the Kuiper Belt is coming to us. That's what I'm telling you. Instead of you going, it is coming to us. The mission was completed with a lander on the object. That is what is called Comet 67P. That Churyumov-Gerasimenko. In my dream also, this name Churyumov-Gerasimenko, they are the inventors or just the people who identified this object. So this Churyumov-Gerasimenko was a beautiful name which is etched in my mind. How human beings can be very ingenuity. What a beautiful ingenuity of the human beings in doing such missions. Okay, next. The future of space travel. That's what I want to tell. Human beings can go to Mars and colonize Mars in 2035. That is possible. The journey time of 10 months may be reduced to 7 or 8 months, but a typical mission will take 2 to 2.5 years for human beings go to Mars and come back. How we will survive the rigors of the space travel and how human beings are adaptable to this experiments are going on. People are staying in International Space Station and getting accustomed to this type of space travel. You cannot carry your food. You cannot carry your water. That is the thing. You have to generate your food, generate your resources as you go. Otherwise, there will be no payload. Only human beings and their food and things only will be there. That is the great. That is the limitations. These are all the limitations. And okay, we can say we can go to Mars, we can colonize Mars. That are all possible. But on Earth, we are thinking about reusable launch vehicles, so that the cost has to get reduced. Only if the cost gets reduced, only our future missions are possible. It's something like a payload of a spacecraft. You can take it that 1 kilogram of a spacecraft is equal to 1 kilogram of gold. That is the cost of putting an object into space, a satellite into space. So this to be reduced. Now, companies like SpaceX are doing a lot of things so that they use the launch vehicle in a reused way. The stages are being used once again and again so that the cost becomes reduced. There are applications for going to the nearby asteroids, mine them and bring some useful minerals and things like that, so that we will be benefited from them. That is all is possible. Next slide, please. So there are robotic missions to the Jupiter's moons are being planned. We are planning missions to Venus. We are planning missions to Sun called Aditya. where we observe. We are going to send a spacecraft called Aditya to the sun to put it in a Lagrangian point, so that we have an observing point on the sun, so that we have a constant observation of the sun and its activity. So our Indian missions to Moon, Chandrayaan 3, and then Mars mission 2, all these are all on the anvil. Indian astronauts called Gaganauts will be traveling in Gaganyaan mission in a couple of years next year. So we have now, like planet Earth, we understand that more than 5,000 similar planets, not of the same size and things like that, they are orbiting elsewhere in other star systems. We understand now such similar planets are there where life may be possible, but it is not a certainty. So this that we only know a little. We know only little. What is known is little, and what is unknown is immense. In Tamil, we say, "Kattrathu kaiyalavu, kalladadu ulagalavu." What we don't know is as big as the earth, and then what we know is only a handful. That is what we do, and we understand that we have lots and lots of things to do, to explore. Next slide, please. So we cannot imagine our life without even a moment in this planet Earth without spacecrafts. Whether it is going around or it is doing all sorts of seamless life, it is integrated into our life seamlessly, and we cannot live without spacecrafts. Our life will still become standstill if spacecrafts just are not there. The human ingenuity, I will call beautiful things which we do. Next slide, please. So I thank you all for the patient hearing, and I hope I gave a very broad bird's eye view of what is possible with human ingenuities. Really, I am thankful to UL Space Club, Kuti sir, Mr. Shaji, and his wonderful team of young people who are going to take the country into its next path. Really, I feel that this is possible, and we are all little old feathers who are ready to fade out, and then welcome the youngsters in carrying on with such missions. Thank you very much.
Thank you, Ingersol sir, for your wonderful presentation. It was very comprehensive and very interesting, and we discussed. It was a total a comprehensive presentation, and it was a lot of interesting and novel factors about, and we all enjoyed in this occasion. And thank you very much for this wonderful and interesting presentation. Then before we go to the questions sessions, that session the students will explore with you to this high altitude of knowledge. And before we go that, our mentor E.K. Kuti sir will make a reflection on this talk. Welcome, sir.
Thank you, Shajil Mash. I think we are back to Earth now, I think. After a wonderful, exciting travel beyond Earth, I think we are now getting our foot firm on our Earth now. So, although we are delayed, sorry for the delay and the inconvenience, and this is the first program of the new year. A very, very happy new year to all of you. And this new year program is notable for the fulfillment of the dream of going beyond the Earth that is made possible by our respectful speaker today, Mr. Ingersol, who so sincere and wanting to make his services available for students to nurture and learn things. So with the first call, he agreed, and we were in a little dilemma because the person who has agreed to talk today got into some personal difficulty, and then I was in a serious problem, and my good friend Indu Kumar happened to come on the line or maybe chat. I just told him there is something like this. Then, without any hesitation, he told me, let me see. And in a little while only it took, and immediately he told me about Mr. Ingersol, and that became a reality in such a short time. Thank you so much, Mr. Ingersol, for accepting our invitation at such short notice and making a fantastic and an memorable presentation. I would say memorable because many of the things in that flight will be very difficult for our students to forget. Now, about Mr. Ingersol already been introduced, but yet I would like to tell you, to make this kind of complex missions possible, the role played by persons like Mr. Ingersol is something very, very unique. See, he works in System Reliability Group. He was the group director of that group, and system reliability ensures reliability, and it ensures quality, and it is the soul and substance of ISRO. The whole thing, the quality assurance, the reliability is the most important component to between the success and failure of a mission. So you can know that the importance of this particular person when and his vision is so visible in today's journey to the beyond Earth. And although we had a late start and we had technical glitches which we never faced at all in any of our 32 regular Saturday sessions and 8 or 9 special sessions, we never faced any such thing. But despite that, we could come out of that. And then see, we had two problems. One is that our link itself did not work, which worked for all the time, but today it refused to work. Then we had to get another link, and Shajil Marsh and our people had to struggle to reach to people to inform them the new link. All these things happened without much difficulty, and I thank Mr. Ingersol for all these things. And today we had two faces whom we never saw in these webinars, ISRO faces. One was Mr. C.K. Ramachandran, who was controller of VSSC long back. He is settled in Calicut, and he is among us in our program, but we got him only today, and it was so nice to see him. And similarly, our Indu Kumar was there today, and it gave me a lot of happiness and interest to see him as this thing. Of course, our usual persons like T.K. Sundaramurthy is already there, Dr. M.R. Shivaraman. I saw some of them, but I don't know many more are there. I didn't see Padmanabhan today. Papan, whose photo was there in one of the slides. He used to be there, but he was not seen. So it is an exceptionally good talk, and I don't have words to thank Mr. Ingersol for his excellent presentation and for his readiness to be with us for all this. Thank you so much, sir. Thank you very much. Sorry for students for taking your time. This is your interactive time. Please go ahead. Thank you.
Thank you, Murthy sir. Then let's invite
Sajid sir. I
yes,
just
sir.
want
Yes.
to
Yes, sir.
make
Sundaramurthy sir. Okay, sir.
few remarks.
Thank you, sir. Thank you very much.
Oh, as the proverb says, without pain, there is no gain. So probably we started here with pain of first we started with, we had a link problem, then we had a problem in the link, but probably what in the Tamil they say, no, ellam nanmaike. So otherwise, I think this was a very good presentation. He has given a crisp complete beyond earth what can be done. He has really brought out. It's in fact I can say that it is not only students are lucky, people like us also are lucky to listen to Chaladurai Saab's thing. It was really very informative, and then it's quite interesting for the students to pick up at least some part of it, and then they can pursue in their career. So with this, yes, as Kuti Saap has already told, I don't want to stand in between the students and then Ingersol Saap's interaction. Thank you so much. All the best for the students.
Thank you, Sundari Murthy sir. As it's a new year, so we have two people from ISRO. We have to get some reflection from their part also. I invite Indukumar sir to make his reflection. Please come, sir. You are first time with us, so we are so happy to be with you. Thank you. Indukumar sir. Sir, please unmute your mic, sir. Okay, sir.
Hello.
Okay, sir. Okay.
Is it audible?
Yes, sir. Yes, sir.
Okay, so good morning and good evening and happy new year to all of you. It is very nice to see all of you in this scenario, and actually I'm seeing E.K. Kuti sir through what you call even video mode, maybe after more than 1 year. When I am seeing him, because even now I feel I am very younger, because I had seen him around 30 years back. The same energy what he is retaining is what you call inspires us also to be part of it. And I am really thankful to Ingersol, because Kuti sir has informed me he had such a difficulty, and within a very short time frame I could arrange it. And really he had given a fantastic presentation. And as he told, for last 1.5 hours we are not in earth, we are all of us were taken to space. Okay. Then I am very happy to see our Sundarajan is actually my ex ISRO satellite center colleague after a long time. Okay, and also this opportunity, then I'm wishing you all the best for the US space program. And it's also my duty, because from launch vehicle fraternity, especially Ingersol has told very clearly, PSLV is our reliable launch vehicle. And very recently, one of our PSLV stalwarts, our S. Ramakrishnan sir, is death has really given a very sad news to all of us. He was the man behind our PSLV satellites, PSLV launch vehicle, and it is my duty to say homage on behalf of all of you to him, and we have to remember him at this moment. He's a great personality. Thank you.
Thank you, sir. Thank you very much for your cooperation, and we expect your continuous support with these students, sir, in future. Okay. Then we have Shivaraman sir also. We know we are so late, but this New Year Eve we have to get reflection from Shivaraman sir also. He is continuously supporting these students for few months. Welcome, sir, Shivaraman sir.
Hello, can you hear me?
Yes, sir. Yes, sir.
Good afternoon. Dr. Chaladurai, your presentation was very good. For about 10 minutes, I had to go out. You are excellent. It was a very excellent presentation, and I enjoyed it. And it was very simple, and the students would have enjoyed and learned something more. These students are very bright, and it is Mr. Sajil and Mr. Kuti who are behind this, and I like their efforts. Has succeeded so much, and nowhere in the country I have seen such a good effort put by anybody else. I am in Ahmedabad at present. I have been telling people to encourage students to start such a program, but nobody is taking care of that. And I should congratulate both these people for their tireless effort. And these students, I think, they will be bringing more glory to our country. Thank you very much, and wish you all a happy new year and a better days ahead for us. Thanks.
Thank you, Shivaraman sir, for your words and blessings. And we, without delay, we are calling our students to make these wonderful question and answer sessions. Welcome, Charudat and team.
Yes, sir. Today we have Charudat with us to handle the question and session. So, Charu, are you there?
Hello.
Yes, sir. Please go ahead.
I have a little internet problem, so I didn't know how I am clear. Am I audible?
Yes, sir. You are audible.
Today, first of all, I am thankful to Ingersol for the wonderful section. The last
Shadil Marsh,
Yes.
Voice has some problem, I think.
Yeah, a little bit. But I think it will clear. Let's wait, sir. 1 minute. It's okay. Let him continue, sir. Charu, are you okay now? Okay, Charudat have some problem with his connectivity. That's the thing, sir.
Okay, sir. What to do?
Who else is there, Varun?
What, sir?
Varun Sriram or somebody is there?
Yes, sir. We are here. Can we ask the question?
Okay, then you, if Charu has a problem, you please carry on.
Okay, sir. Okay, sir. Thank you, sir. Let me ask the questions. So we have few questions for today's question and session that we have collected already. Let me ask you one by one. The first question is from Akash Vinod. The question is, what are the chances that satellites reach the undecided orbits? That's the first question, sir.
Ingersol, sir, your mic is muted, sir. Still it's muted.
Yeah, I am listening. I want the students to respond. Can I respond actually?
Yes, sir. They want to get clarification from your part, sir.
Okay. If I am to give the answer, I will straight away give the answers. I thought these chances of these spacecrafts being put into low orbits than what is decided is always there. If the launch vehicle underperforms or overperforms, if one of the stages didn't activate, always there is a chance of the spacecrafts underperform and then fail to reach their orbit. In fact, we had a typical failure like this when the heat shield of a PSLV launch vehicle did not open and the spacecraft was cocooned inside the heat shield, and still it is going around the Earth with its heat shield around it. So the spacecraft is not going to be useful. So as Kutisar told, the reliability of these systems, we expect a reliability if the launch vehicle has got a big history behind it or its development is good enough. Then we have a reliability of something like 80% or 85%. But to start with, the reliability will be around 70% only. So there is always a chance of failure, but we work to prevent these failures. Failures are a possibility, and failures are our learning methods also. Our stepping stones to success are from failures only. Failures teach us more lessons than success. Success makes us complacent, whereas failures makes us learn more.
Can I ask the next question?
Yeah, please.
So the next question is from Adidev. He's one of the active students of UL Space Club. So the question is, sir, I heard somewhere that India is planning rocket reuse. If we are reusing rockets, on rocket will it be GSLV Mark II or some other rockets?
Okay, we are planning the GSLV Mark II rocket it is all in the preliminary stages. The earth-lit stages or the ground-lit stages, whether we can recover the hardware and then reuse it. That is our first aim. But then it is all only in the preliminary thinking process. I can say that JSLV Mark II liquid stages are more can be reused because the tankages can be brought back, the engines can be brought back. But we have to think a lot. We have to do a lot of experimentation in bringing them back, and then how the hardware can be continued to be reused is a question of testing its capability to be flown again. These are all things. While you design the launch vehicle and its constituent components, if you are designing for reusability, it is fine. But once you have designed an expendable vehicle and then trying to do these things, it is going to be a little bit complex. So our future launch vehicles will try to have some reusability. ISRO is thinking of.
Okay, sir. Charuk, do you want to ask the questions, or can I continue with? Hello, Charut, are you there?
I think he couldn't join it.
Hello?
Yes.
Please continue.
Hello.
Okay. Chari, with your permission, let me continue with the question session. So next question is from Hariharan K.R. He has asked that, sir, can you shed some light on helium-3 deposits on the regolith of the moon and its relevance to the Chandrayaan-3 mission that you are talking about?
Helium-3 is a deposit which we can take from moon probably and can be used for fusion power. The fusion power generation still in Earth it has not been done. The way in which power is generated with atomic resources, it's still with fission only we are generating power using uranium. We are splitting the atom to generate power, but using helium-3, fusion power is possible. That is what scientists say. But the feasibility of making the power in moon and then transmitting as a microwave into Earth, that is also possible. Or transporting helium-3 and then bringing it back and then generating fusion-based power is possible. But these are all long-term things. I feel that even to get nuclear fusion-based power, it's 30 years away. Still, to that time, we have to live with our own power sources, the expendable power sources which are available on planet Earth. But fusion-based power is going to be little more benign or unfriendly power generation, and lots of power can be generated in that method. So fusion power by taking resources from helium from the moon and either bring it back or do it there. I was telling about now an industrial base can be set up in moon, and human beings can plan to live there for short times and then do some industrial works like this. It's all possible. Whatever man has imagined, he has done it. And this is a technological age, and it is quite possible. I won't say it is improbable. It is probable and possible.
Yes, sir. Like you said, it's some difficult process. So Hariharan has a same continuously. He has a doubt on helium-3 deposit. The research on that. The question is, how feasible is the helium-3 deposit mined from the moon or ground for on-ground energy applications?
Yes.
Considering the cost of transportation, it will be really costly, right?
Yes, definitely it is a costly process. To bring something, a few grams of moon soil has only been brought so far from moon to Earth. To bring tons and tons of such thing and reprocessing it as a helium-3, we cannot get it straight away from moon. We have to bring it back and then take it and actually we have to rejuvenate to get it helium-3. But the future of the world is in fusion power. That is what the philosophy is. Nature teaches us many lessons. The sun generates its energy with fusion power. It sets an example of radiation-free or radiation effects-free power only with nuclear fusion. Only human beings have generated this fission power, in which we have radioactive dangers. So nature tells us make fusion power. That is a message. We have to take it, and then based on that we have to devise our technology to generate fusion power, which will be a permanent source of power. This is what I philosophically believe.
Okay, sir. The next question is from Eldo Samwagis. He is also an active member of a webinar series. He was participating in all webinars. So his question is, sir, I heard about space elevator. Is it possible to create it?
Okay. The way in which you can reach space, suppose you have a structure in which you can climb and go into space. It's all it's like fiction right now, but universities elsewhere are working on such things, and it may be possible. I won't say it is impossible. Just to climb into space and then go into space using laser-based lift, you can go. It depends on the payload which is trying to go into space. That is possible. It's possible, and people are working on it.
Okay, sir. The next question is from our respected Shivaraman, sir. So let me ask the question. What went wrong during landing of lander on the moon? Do we have enough data collected and find out?
Yeah, we know what went wrong. There was a software related problem, and also the propulsion system's behavior during the final phase probably was not characterized fully, and that is one thing. It's all doubts. No, you cannot. The data is available, but the data rate with which we receive this data is very small. The rate at which we receive the data is small, but to characterize a propulsion system for its full behavior, it requires a huge bandwidth to understand why it has behaved like that. So it's a question of little insufficient data now to fully understand what has gone wrong. But definitely the software part is correctable. It is correctable with some simulation part. So instead of softly landing, the direction of the force was on the opposite side, and we landed harshly or forcefully onto the surface of the moon, and probably the spacecraft was split into multiple pieces. That's what the data shows us. And definitely it was a last leg. We are almost 3 kilometers above the surface of the moon. Everything was excellently going on, and finally that software related thing troubled us and put the force in the other direction. The orientation of the spacecraft was put into another direction. That's what we believe.
Okay, sir. Thank you for that. We have two more questions. First one is from Harida. Hello, sir. There are many dead satellites as well as remaining such satellites in space. Are any steps to taking clear this? It's very relevant from when we are talking about outer space orbit and travel beyond that. So she was asking about the debris. Please, sir.
Yeah, now earlier we used to put satellites in well-defined orbits, like a polar orbit or a geostationary orbit or low Earth orbits. But now each company is coming out with constellation of satellites in different orbital planes and different heights from planet Earth. The need for high-speed internet and then high-resolution pictures. So the demand is there to put so many of these satellites into orbit, and the space is becoming a junkyard probably, and we have to now there are missions which during the final phase, how to phase out the life of the satellite is also being thought of. Leaving some fuel in the spacecraft to use it for de-orbiting to a far-off place. The satellites are also having a graveyard orbit. You can put them away into a graveyard type of a thing. That's possible, but you should have enough fuel left on the spacecraft even during its useful time period. You should plan for it. That is an end-to-end thinking process should be there. And useful time of the satellite will be lost if you de-orbit, but yet we have to think it as a space junk and has to do it. So these are all economical criteria. And to grab satellites and then bring it back and throw it into the lower Earth orbit so that it gets burnt, that's possible. Refuel the satellites in orbit, like grab the satellite, refuel it, and put it back. These are missions which are possible. But we have not thought of first, we don't think about the garbage, no. Even in normal life, we want to consume, that's all. We put it into the neighbor's backyard. That is our normal practice of handling garbage in earthen systems. That we have started doing in space. Now methods are there. You would have read that Japanese people are making spacecrafts with wooden parts, with wood, so that as it deorbits, it will just simply burn off. But these are all thinking in that line, and it's possible. It is going to happen. Otherwise, it will be harmful to our life. Our own view of the universe itself is going to be blocked by this satellites.
Okay, sir. That was that question, and we have this program is going on live stream in YouTube channel. UL Space Club has a YouTube channel, and there's a live stream of this program in our YouTube channel. From there, we got a question, and that's one of the most relevant question to this topic. That most of us may have a dream to travel beyond Earth's orbit. So, what should be the educational qualification of an astronaut? That student asked a question that what should be the educational qualification of an astronaut? What should we study for that?
I would say you should study physics and mathematics at your younger ages in a very strong way, and have good health. Basically, these astronauts are selected from armed forces or the air forces. Basically, they come from the Air Force training. They are trained to be physically strong, physically rugged, and then mentally very brilliant and active people who can handle situations in a calm and in a wonderful way and an efficient way. That psychologically also they will be tested for such things, and they should have wonderful physique. And they basically the captains of these space missions come from the Air Force or pilots, basically pilots who are trained to do that. And otherwise also, now this technology is transferring such that ordinary citizens can go into space as a tourist. That is also possible. Paying huge sums of money, that is possible. And as payload specialists also, people from physics background and things like that, who can devise experiments and then carry it out in space. But basic thing is they should be able to survive the rigors of space. They should be psychologically very stable. These things are very important. And human beings are not designed for space travel for a longer period of time. So these are things which one has to keep in mind. But the basic studies is, I would say that study mathematics and physics as if it is, it will go take you to the orbit, and then study, get into the armed forces and probably get as a test pilot and then come here, or go into a simple payload specialist. Okay. Or travel in space if you have huge money, some hundreds of crores of money, if you should have to travel to space.
Okay, sir. Thank you, sir. Thank you for answering the questions. The questions were collected from the chat window and from the YouTube. That was really, it was my pleasure to get an interactive session with you. Thank you, sir. Thank you for that. And we are very happy because we were worried about the link issue, but still there is 34 participants are there. So that was really nice, and it was a wonderful talk by you. It's a most exciting topic in space science, travel beyond Earth. That was an inspiration for the space exploration for me. So Shadisa, over to you.
Okay, thank you, Varun and team, for wonderfully handling these questions session. That's the most interesting session in all our webinars, and we are watching your improvement in your articulations, and it's also a skill in asking questions and managing things. That's the thing we want from you. We want to make some output from our students, and it's a good forum to make that output and explore these genius like Ingersol says. And we are wondering on your wisdom and your experience. You are talking with your direct experience and wholehearted work with ISRO. We are proud of you, sir, because you are behind the recent success from these great organizations. And we are so proud to be with you, and we want your support in future also, sir.
Definitely.
To nurture our students, we think that as a teacher, we think that we have the duties to nurture our students. It's a good environment. There is no barrier of state or language, anything. We can nurture the students all over India. That's our aim. And we are so proud, and we have good guidance and leadership from E.K. Kuti sir, and the entire team is with us, and we are so thankful to you, sir. Next, we are concluding these sessions wonderfully, even though it was started a little bit late, but we are enjoying these things. And before we go to the vote of thanks, formal vote of thanks, usually there will be a declaration from E.K. Kuti about the future things or the perspectives, and I welcome Kuti sir again to make things, sir. Okay, thank you.
Thank you, Shadil Marsh. Already this time is too much, already coming close to 5:30. We began at 3 and almost 2.5 hours straight long. I have nothing else to say except that this has been an extraordinary session, a very exciting session, and topic itself is an exciting one, and it is very exemplarily handled by our chief guest Ingersol, and thank you very much. We will have our next sessions only next month because schools having been opened. We have now embarked on a monthly webinar instead of weekly webinar. So the next one will be on 13th February, and we will announce the topic and the speaker in due course. So that is all, and thanks very much, Ingersol, Indu Kumar, and all of you. Thank you so much.
Thank you, Kuti sir. Next is a formal vote of thanks from our part. I think it has to be done by, usually it was done by our Damodar sir. Now today is not available with us. And I invite Ashwini Orti to make it a vote of thanks officially. Ashwini, welcome.
Okay,
She's
sir.
the
Am I
gifted
okay?
student. Yes, you can.
Okay. Hi all. Good evening. First of all, I wish a happy new year to all. It was our 32nd webinar in the UL Space Club webinar series and the first one in the 2021, and it was a good start for the new year. Today, the session was handled by Shri S. Ingersol sir, who is the Group Director of LPSC in ISRO. Today's session was on the topic A Travel Beyond Earth's Orbit. A world outside the Earth or a journey beyond the orbit of the Earth is always a curious thing. It was a wonderful and very informative one. Thank you so much, sir, for setting aside your valuable time for us. And thanks to all veteran scientists who are present here. Thanks to our mentor, Shri E.K. Kuti sir, moderator Shadil sir, all the student coordinators of UL Space Club, and special thanks to all the participants who had attended the webinar. Thank you.
Okay, thank you, Ashwini. Let's conclude this wonderful day and wish you again a happy new year. And we will meet on the 13th of February next month. Okay.
Yes, sir. Before leaving, I just want to request all participants not a group link. If anyone is not part of UL Space Club, you can join our public WhatsApp group, which is admin-only group. It's to give you the updations of UL Space Club programs and to give you space-related informations. So you can join that WhatsApp group. One of our members will post the group link in the chat window. And
Varun, what about the link? What about the Q's link?
Yes, sir. Q's link. I was coming into it. One of our members
link will be posted now itself.
Yes, sir. The Q's link will be posted now. So all of you are requested to attend the Q's. So please don't miss it. The first prize winner will get a cash prize, and the second and third prize winners will be awarded by a certificate from UL Space Club. So don't miss it. And the winners of the Q's will be selected to a special event that we are thinking about it. And that's all about it. So Sriram, could you please provide the WhatsApp group link in the chat window?
Yeah, sure, Varnata.
It's only for those who is not a part of UL Space Club. Cosmos group members are strictly prohibited to join that group. So it's for those who are out of UL Space Club. So you can join with that link.
Okay, the students will get the link from the comment box and wish you a good attempt in this. And then all the questions are based from the presentation from our Ingersol sir's presentations. Okay.
So we have your permission, Shadil Marsh, to quit.
Yes, sir. Yes, sir. Thank you. Thank you very much.